Have you ever wondered how a small pellet of nuclear fuel can generate a massive amount of electricity? It's all about nuclear energy, a force so potent it boggles the mind. This power is harnessed in a nuclear reactor, a marvel of human ingenuity that controls nuclear chain reactions. Imagine, if you will, the ability to command the very forces that light up the stars. Intriguing, isn't it? Let's delve deeper into the heart of a nuclear reactor. Imagine a city's energy, all humming from a machine the size of a small house. That's the magic of a nuclear reactor. Nuclear reactors are powerhouses of energy conversion. At their core, they house a fascinating science experiment that harnesses the power of atoms, specifically those of uranium or plutonium. These elements are the nuclear fuel that powers the reactor. Each uranium or plutonium atom in our nuclear fuel is like a miniature bundle of energy waiting to be released. It's like a tightly coiled spring, just waiting for the right nudge to set it into motion. And that nudge comes in the form of a neutron. When a neutron strikes a uranium or plutonium atom, it sets off a process known as nuclear fission. This is where the atom splits apart, releasing a huge amount of energy in the form of heat. But that's not all. This process also releases more neutrons, which then go on to strike other atoms, setting off a chain reaction. Now, it's easy to imagine this as some sort of atomic domino effect, where one atom sets off the next in a rapid-fire sequence. But in reality, it's a controlled process, maintained by control rods that absorb excess neutrons. This ensures the chain reaction doesn't get out of hand, but continues at a steady, manageable pace. So what do we do with all this heat energy? We put it to work. The heat from the nuclear fission process is used to turn water into steam. This steam then drives a turbine, much like the wind turns a windmill. And as the turbine spins, it generates electricity. And there you have it. A nuclear reactor isn't just a giant kettle boiling water with atomic heat. It's a finely crafted system, where every part has a specific role to play, from the nuclear fuel to the control rods, from the heat to the steam, and from the turbine to the electricity it generates. So, that's how a nuclear reactor works. A finely tuned balance of science and engineering. Now that we know how nuclear reactors work, let's consider why they matter. The benefits of nuclear reactors are manifold. Firstly, they are incredibly efficient. A single nuclear power plant can generate a vast amount of power, enough to sustain a large city. Moreover, nuclear reactors have extraordinary longevity. Once built, they can operate for several decades, providing a reliable source of energy. This is an advantage over other renewable sources, which may be intermittent due to weather conditions. Another remarkable feature of nuclear reactors is their fuel efficiency. They can generate a colossal amount of power from a minuscule amount of fuel. This makes them a cost-effective solution in the long run. But perhaps the most significant benefit is their environmental impact. Nuclear reactors emit virtually no carbon dioxide during operation, making them a crucial ally in the fight against climate change. Clearly, nuclear reactors have a significant role to play in our energy landscape. Now, let's summarize what we've learned today. We've embarked on a journey into the heart of a nuclear reactor, where we've seen science and engineering combine in phenomenal ways. We've delved into the intricate process of nuclear fission, where a single atom is split, releasing a tremendous amount of energy. This energy is not just abstract, it's practical, it's usable, and it's what powers our homes, our cities, our world. The nuclear reactor is an impressive feat of human ingenuity. It's where this energy is harnessed, where the heat from nuclear fission is used to generate steam, which in turn drives turbines to produce electricity. It's a process that's efficient, powerful, and when managed correctly, remarkably safe. We've also explored the benefits of nuclear reactors. Beyond their impressive power generation capabilities, they offer a form of energy that's low in carbon emissions, helping us combat the ever-looming threat of climate change. They provide a reliable source of energy, operating continuously, unaffected by the whims of weather or the cycle of day and night. In essence, nuclear reactors are a testament to our ability to harness the fundamental forces of the universe for our benefit. They're a symbol of our technological prowess and our commitment to a sustainable future. So, next time you switch on a light or charge your phone, spare a thought for the incredible science and engineering that makes it all possible.